Organic light-emitting diodes, OLEDs, are made using organic carbon-based materials. Unlike LEDs, which are small-point light sources, OLEDs are made in sheets that create diffuse area lighting. As a result, OLED lighting offers a range of qualities that could expand design opportunities for both commercial and residential lighting.
An organic LED is a light-emitting diode that's comprised predominantly of organic materials, closer to petrochemical and oil than they are to living, breathing things.
OLEDs have just started. I think a year ago there were 4 or 5 companies that offered an introductory OLED product, so it's sort of a limited production. They were quite pricey.
OLEDs are a next generation lighting technology, and OLEDs have some real strengths.
Given the characteristics of OLEDs, which are non-glare and really nice to look at a low temperature, they can be deployed quite close to the user. And that itself would bring tremendous advantages.
OLEDs are always being considered as a really beautiful light source. They are a diffuse, large area light source.
It doesn't have the glare that you normally see with a light bulb.
OLED can really be made very, very thin, can potentially be made on a very flexible substrate, and it can also be made transparent.
A light source that you can hold into your hand and maybe apply to a wall or even quiver around something.
The aesthetic and energy savings potential of OLED has been shown in the manufacture of panels, the light-emitting devices used to construct a luminaire. However, key barriers are inhibiting the commercial viability of OLED lighting.
Sure, like with the first year of any product introduction, OLEDs have quite a ways to go in cost reduction.
There's a great deal of work yet to be done, mostly on the research side.
I call it the 5 cost killers of OLED. All of them need to reduce cost greatly for us to gain a market entry point. It's substrate, the stack, the encapsulation, the production equipment, and then materials.
Most of the materials used in OLED today are not remarkably soluble. A lot of them are really rocks, so finding a solvent to put them in is quite difficult.
OLEDs are at a point where there's no standardized current or voltage, and depending on the number of panels you use, if a small number of panels, you might need a customized driver solution for that.
There are a lot of questions around lifetime. So what is it that limits the lifetime of the emitter? It doesn't live forever. You can only excite it so many times before it degrades.
When the device actually emits a photon, it gets trapped in the glass, in the organic layers themselves, in the metals. And our challenge is to get all of that light into the viewing angle so that when somebody sees the OLED, they're seeing the full efficiency of that device rather than having light lost in the various segments.
DOE's solid-state lighting program brings together lighting experts at a national level and focuses OLED research efforts on the development of novel materials, structures, and processes. The goal is to create a highly efficient, stable white device that can be cost-effectively manufactured to maximize U.S. economic and environmental benefits.
DOE support makes a huge difference. They have 3 aspects to the funding. There's the core research, the product development, and the manufacturing.
Bringing different partners together working on the same exact system is really important to make it more efficient.
DOE has done a very good job of coming up with a roadmap of projected costs that will get us to a worldwide competitive large volume position in OLED lighting where we're selling lots and saving lots of energy.
The entire intent is to produce market-ready product at a reasonable cost.
DOE funding is critical to get people over the barriers to start building the first facilities to prove out the technology.
5 years from now, I think we'll find OLED lighting in common use in commercial applications, having achieved a significant foothold in the lighting market.
With continuing advances in efficiency, output, and lifetime, as well as lower costs at all stages of development and production, OLEDs could provide dynamic, unexpected solutions in general lighting that save energy, reduce emissions, create jobs, and enhance our quality of life.